Hello, friends. We are going to look at special quadrilaterals and polygons today. I'm still looking at finding the area of these things. We spoke about polygons before we broke for spring break when we were still together. And remember, we know that polygons are closed shapes. They have straight edges, they're two-dimensional, and the line segments do not cross. So up here we have examples of polygons. We've got some rectangles, we've got rectangles with the corners cut off, we've got some irregular shapes, and so forth. These are all polygons. Down here are examples of things that are not polygons. These two have rounded sides or edges, so they're not polygons. These are open figures, they're not closed. This shape, the line segments cross, as well as this one here. And then this is a 3D figure. So none of these are polygons. So let's take a look at some special quadrilaterals. We've already talked about parallelograms, and we figured out how to find the area of the parallelograms, which is just multiplying the base times the height. We also have trapezoids. Trapezoids are quadrilaterals with exactly one pair of parallel sides. So parallelograms, both opposite sides, pairs of sides are parallel. In a trapezoid, only one opposite side is parallel. As you can see, this side here on the right and on the left, if we were to continue the sides up, they would eventually cross. So like this, but parallel lines never cross. So in a trapezoid, we can find different ways, we can do different things to find the area of a trapezoid. The first thing that we can do is create a copy of the original parallelogram and rearrange it and compose it next to each other like that, and we are going to create one big giant parallelogram. Well, we know how to find the area of a parallelogram, so this is easy now. So we have to figure out the height and the base. So in a trapezoid, we have two bases. The base here at the top is 8, and the base here at the bottom is 10. So this is base 1 and this is base 2. When we made a copy of this trapezoid, the bases are the same, but I flipped it upside down. So now this bottom base here is 8 and the top base is 10. So when we stick these together, we're going to have new measurements here. So we've got the base of this original parallelogram, I'm going to make it a different color, is 8. And the copy, when I flipped it over, it's the same as it was originally. It's 10. And then this trapezoid is the base here, down here at the bottom is 8. So in order to figure out the area of this giant parallelogram, we need to figure out the base and the height. So we can use the bottom line as our base, and because it's 10, we know this measurement here is 10 and this measurement is 8. We can say that the base is 10 plus 8. So the base in this new parallelogram is going to be 18. And we can see here that the height is 6. So if we take 18 times 6, then we know that our area of this entire giant parallelogram is going to be, using your calculator, is 18 times 6 is going to be 108, whatever the unit is, squared. So that's the area of both the red and the gray portions together, 108. We want to know what the area of just the red portion is. So because we made an exact copy of the red trapezoid right here as this gray trapezoid, and we stuck these together, we composed them into a composite figure, we know that the big giant parallelogram is 108 units squared, but we only want to know what the red portion is. And since that's exactly half of the big parallelogram, we can take half of 108 or divide 108 by 2, and that's going to give us 54 units squared, or square units. So that's the area of this red trapezoid. So that would be one way to figure out the area of a trapezoid. And we can make that into a formula. If we look at the next page, we've got our formula here for the area of a trapezoid is base 1, the measurement of base 1 plus the measurement of base 2 times the height divided by 2. So if we go back to this one that we figured out here, we've got base 1 is 8. We're going to add it to base 2, which was down here, but we added it up here, which is 10. So we did that down here. 10 plus 8 was 18. Then we multiplied these two bases together times the height, 6, and we got 108, and then we divided that new area by 2 in order to get 54 square units. That's how we come up with the area formula for a trapezoid. So again, the area formula for a trapezoid is base 1 plus base 2 times height divided by 2. There's another way to find an area of a trapezoid by decomposing, rearranging, and figuring out the area of the parts. So in this case, I've actually already sectioned this trapezoid into pieces. You can see right here in the center, and I'm going to color this, what color? Orange. This is a square. We can see that that's a square. We know how to find the area of a square. That's super easy, base times height or side times side. And so the top measurement of the square is 10, and the height of the square is 10 as well. So the height of the square is going to be 10 times 10, which equals 100. Then we still have these things over here on each side, which we know these things are triangles, right? And they're exactly alike. They're exactly the same measurements. We know the height is 10 because when we had them back here together, it's the same height as what the square side is. So we know the height of the triangle. Move this a little bit here. We're going to label this triangle. The height of the triangle is 10. And how can we figure out what the base of the triangle is? Well, if we put this triangle back over here next to the original square, so we can see our original trapezoid, you can see that this whole base, what we called back on this slide back here, the base 2, this whole base 2 is 30. Okay, and the base 1 up here at the top is 10. So if base 2 is 30 and we take a triangle away from here and this triangle away from here, instead of this being 30 now, we know that this length is the same as this length, so it's 10. And because these two parts are exactly the same, we know this plus this is 20. So half of each has to be 10. So let me just label those for us. We have 10 here and 10 here. Okay, and let me label our height of our triangle. Now these are both right triangles because this height here, the 10, was at a right angle. So these are now right triangles. And we know that an area of a triangle is base times height divided by 2. So the triangle, this one right here, is going to be 10 times 10 divided by 2, which, when we do that in our calculator, is 50. This triangle and this triangle are exactly the same. They have the same measurements. So we know that this is triangle 1. We know that triangle 2, the measurement is exactly the same. So it is 50 as well. So we can figure out the area of our original trapezoid by adding up the area of the square, which we said was 100, and adding that 100 to the area of each of those triangles, which we said was 50. So our original trapezoid, the area is going to be 50 plus 100 plus 50. So the trapezoid is 200 units squared. All right, so just breaking a trapezoid into parts that we know how to find easily, like squares or rectangles and triangles, we can decompose our trapezoid, figure out the area of those things, and then add them back together. Now, I have 2 more slides that I want to cover. Those are polygons, and I'm running out of free time for me to record. I only get 15 minutes of free recording time without having to pay for this program. So I'm going to stop this video right now and create a whole nother video to show you how to find the area of hexagons and octagons. So I'm going to end this now and make a new one.